Now, in this lecture, I will be explaining implementation of BERT in PyTorch from scratch. So what is pre-training? You can see my previous lecture. What is pre-training masked language model? You see, you mask some token and you see what is the probability of one word. And next sentence prediction, we separate with this token and of course we can use mask as well. And then we see what is the probability of is this sentence the next one. For example, this is with 99% probability, it is not the next one. And for example, the man went to the store, he bought a gallon of milk. So it is next because this one is related to this. But penguin, for example, is not related to heading to the store. So let's implement BERT from scratch. What we need embedding layers, attention mask, encoder, multi-head attention, scale.product attention, position-wise, feed-forward network, and finally we need BERT assembling all of these components. So for BERT embedding, first of all, we have in its method, the initializing, we have token embedding. As I said, if you add token embedding and position embedding and segment embedding, you get the embedding. And for the forward one, you see, you just add them. You just add these different embeddings of a token, and then you add it. So what I was saying that, and what is position embedding? Position embedding, for example, if we don't use this sine and cosine, do you know what happens? When it, for example, if you, for example, this is at time step, for example, 3 or 10. At time step 10, for example, you're adding a very big number, or the previous one 9. You're adding a very big number, so it ruins all these values. It's like, for example, if you know electrical engineering, we want signal to noise to be high. We don't want to noise to corrupt the signal and outperform the signal. Dominate the signal and destroy the signal. We don't want that. That's why this beautiful idea of position embedding comes to rescue. And if you just use this, so it's like scaling that so that it works fine. So the implementation is very easy. You see sine and cosine of torch. We use that and we give it position. So this is just a position embedding. And finally, in segment embedding and token embedding, as I said, they're very simple. So let's talk about position-wise feed-forward. You know, we use the standard feed-forward, but we also use dropout. And for activation, for example, we use GELU instead of RELU. We use GELU. And the implementation of GELU is just 0.5 times 1 plus tangent hyperbolic of square root of. So the next component is layer norm. We initialize the parameter. When we say n parameter, it means in PyTorch, it means that you should learn that. It's not variable, so you should learn. So it's part of the parameters that is being learned. And so when we forward that, it's just normalization, x minus mean of that and standard deviation and plus epsilon. And what is a sublayer connection? I've explained it in my lectures. If you watch my lectures on transformers, deep learning projects, playlist, I guess. And so I have explained it in several different lectures. So, what is multi-head attention? So this attention, I will explain this attention here. So the attention that we use is just a simple formula for attention. Score is become math multiplication. It tells PyTorch that you should multiply two matrices. The query times key. And key transpose, you see, key dot transpose. So key dot transpose dot q. And then you know that you should mat multiply with value as well. So dot value. So this is the attention. This is the implementation of attention. Very simple. For transformer block, you just need, it depends on you, but the standard way is first you should you should give it to sublayer, and then the output sublayer, which is a sublayer connection that I explained. So the input sublayer is a sublayer connection, output sublayer is a sublayer connection. So it's a standard transformer block, and you can just add these and create bigger and bigger architectures. But BERT, as I said, it has 12 layers, 12 of these layers. And the default is hidden layer. You put hidden layer 768, the dimension of hidden state dimension, h of dimension. And so here in BERT, we are, so at initialization, we say that BERT, what is embedding, BERT embedding, and we initialize all of these things with the vocabulary size and embedding size. So embedding, as I said, for sum of position and segment and token embedding, we have implemented before. So in the forward of BERT is very simple. You just embed it, that plus three things, embed it and give it to the transformer. After we have embedded, give it to the transformer. The transformer gives the output, and this is the output of BERT. That's it. So what is the BERT language model? For initialization, first you say, because we have in pre-training, we have two tasks, mask language model and also next sentence prediction. We have two tasks. So you return two things, not only next sentence of X, but also mask language model as well. So this is the implementation of next sentence prediction. You see, it's just softmax of linear thing. It's very simple. And the same thing for mask language model. The implementation of mask language model is just a linear layer, a softmax of a linear layer. Because we have everything is in X. X is in, you will see how you can connect these things. The important thing is that because pre-training in BERT is composed of both mask loss and next sentence prediction loss, so we add them. So the total loss goes to the backward and get the backpropagation for the backpropagation and updates the parameters. So for criterion, we use, this is negative likelihood loss function. And what else you should know? I think that's it. You have implemented PyTorch from scratch. So it's very easy. And so you see that if you implement it from scratch, it's very easy. But in the next lecture, we will talk about how to use a transformer library.